Okay, so before we start the notes for section 3.4, which is talking about graphing, and we're going to use a couple different concepts to help us figure out what the graphs of these different polynomial functions look like. But before we do that, let's just kind of review in general what polynomial functions will look like based on their degree. All right, so the first and simplest polynomial function is what we call a constant function. You might think like, oh, it doesn't have a degree. Well, if you think about it, you could put an x to the 0 next to that constant too. And so now it looks a little bit more like a polynomial, I guess, because it's got a variable there. And so it makes sense that this is a degree 0. And notice that the line does not cross the x-axis. Unless the line itself is the x-axis, you're not going to be crossing the x-axis. Okay. All right, so as we increase the degree, we sort of increase the number of solutions that we could have. So this is clearly a degree 1 polynomial. We refer to this as a linear polynomial, linear function. And notice it has exactly one solution. And let's increase the degree then. So this one now has degree 2. Notice as we switch from degree 1 to degree 2, we have a change in direction, right? So before it was degree 1, and sort of the endpoint behavior was that they were going in opposite directions. Now we have a degree 2, which is even. Now our end behaviors are that they're going in the same direction. Notice too that the leading coefficient, which is 1, right? It's not there, but we know it's positive 1, also tells us what direction these end behaviors are going in. All right, let's go to degree 3. So notice with the degree 3, we have another change in direction. We have the potential here of having two solutions if we were looking for where this thing crosses the x-axis. If we set this function equal to 0, we would have a cubic equation, right, that we would solve, and we have potential for three real solutions. Could just be 1, or it could be 3, depending on how many times we cross it. Now we know it's degree 3, which is odd. That means one side is going down and the other side is going up. So at some point we're going to cross the x-axis at least once, but in this case we crossed it 3 times. All right, let's increase the degree again. So now we're going to have a degree 4. We have a degree 4. What do you think that will look like? All right, so we have another change in direction. In this case, we change the direction again and we go back up. So now note that the degree is 4, which is even. So they're both pointing in the same direction. So the end behavior is that they're going in the same direction. When it is odd, notice that they go in opposite direction. Also notice that we have 1, 2, 3, 4 real zeros because this thing happens to cross the x-axis 4 times, which is in agreement with the degree. Now it doesn't mean it has to cross it 4 times. Sometimes it may, in this case, it may not really cross it at all. It might cross it twice, right? So there's some options with when you get these higher degrees. All right, so let's just look at some examples of other functions. So this is a degree 2, a quadratic function. So think about how this will graph. All right, notice that again, the degree 2 is even, so they're both the end behaviors is that they're pointing in the same direction, but this has a leading coefficient that's -3, and that's why this is opening up down. All right, so here's a cubic. The leading coefficient is positive. It's degree 3. Kind of visualize what you think this will look like. All right, so this one crosses. It doesn't have to cross 3 times. You can see if the whole thing shifted up a couple of units, it would cross once, but then this would not intersect the x-axis. And so we would just have one solution, but it's odd degree, so they're going in opposite direction. The end behavior starts left, starts down, and as x gets bigger, it goes to positive infinity. All right, so here's another cubic. Now this is just kind of a wacky looking one. It looks almost linear. If you put a straight edge on here, you'll see that there's a little bit of a curve to it. The whole point of this is, well, there's only one real solution, and then there's a little squiggle to this what, kind of at first might look like a line. And so that sort of eats up two more solutions. So we have one real solution here. It passes through the x-axis clearly. And so two of the solutions will be complex because we know there's three solutions. Two will be complex, one will be real. But notice the end behaviors, the leading coefficient's positive. It's an odd degree, so it starts down, ends up. All right, here's a degree 4. Notice in this case, it looks sort of like a parabola, except it's flat on the bottom. Okay, and you can see here is one example of a kind of a classic degree 4, and also here's one we saw before, classic degree 4. This case we have just two solutions that are real, 1 and 2, and then we'll have two more that are complex. Remember, the complex solutions always have to occur in pairs. It's an even degree, so they're both pointing in the same direction. The leading coefficient's positive, so they are pointing up. All right, and degree 5. So this is sort of the what you might think of as sort of the classic degree 5. It indeed crosses the x-axis 5 times. So there are 5 solutions here. So -2, -1, 0, 1, and 2 are the solutions we can tell from the graph. The degree is odd, so their end behaviors is that they're going in opposite direction. As x goes to -infinity, y is going to -infinity. As x goes to positive infinity, y is going to positive infinity. That is the end behavior, and that's because the leading coefficient is positive. All right, here is another degree 5. Again, they don't all have that classic crossing the x-axis 5 times kind of look. If we try to actually solve this one, we can solve this equation. If we set it equal to 0, we can solve this one by factoring. So if we factor the GCF out, which is x to the 4th, we would get x to the 4th times the quantity x plus 3. And then we can set each of those factors, x to the 4th and x plus 3, equal to 0, and then solve those. So we have an x equals 0 and an x equals -3. Now you might say, oh, well, there's only 2 solutions. I thought you said there's going to be 5 solutions. Well, what happens is this 0, we've seen in the past where a solution can have a multiplicity of 2, right? We have a repeated root. In this case, we have it repeated 4 times. So we have a quadruple root here. You can see it comes down, touches it just tangentially, and then bounces back up. So that is going to be, that's what happens when we have an even multiplicity. So if we have multiplicity of 2, in this case we have multiplicity of 4, the graph is going to come down, touch the line, the x-axis just tangentially at that point, and then bounce back off. It's not passing through the x-axis. So when the multiplicity is odd, 1 or 3, then it's going to pass through at that point, possibly tangentially, possibly just straight through like it does here over at -3. Okay, that has a multiplicity of 1, so it passes straight through it. If it's a multiplicity of 3, it'll come down tangentially and still then pass through it, as opposed to an even where it will bounce back off and go in the reverse direction. All right, so these notes are section 3.4. We're dealing with how to graph polynomial functions. And instead of getting like the exact graph, what we're going to do is we're going to use a couple things to figure out how to graph this. We're going to look at the location of real zeros. That means where does the graph cross the x-axis? We're going to look at y-intercepts. Where does the graph cross the y-axis? Those will give us extra points to graph. And then we'll also think about end behavior, whether the degree is even or odd, and then also look at the leading coefficient. Would it end up being positive or negative? Now, all of these are in factored form rather than in sort of the general, multiplied out form. So we'll have to think about maybe what would the leading coefficient be? Would it be positive or negative? And what would the degree be if we multiplied it all out? Okay. And then we might also just pick some other x values to plug in to see. So we'll plot the real zeros, we'll plot the y-intercept. We'll see if maybe we want to plot a couple more points, and then we'll decide, kind of like what the graph looks like. All right, let's look at number one. All right, so this is going to have two solutions. We set each of those binomials equal to 0, so we know that the solution is going to be at 2. And another solution is going to be x equals -1, so we're here. And this is also a degree 2. If I FOIL this out, this would be a quadratic. So that means we're going to have a parabola. So think about whether or not this parabola opens up, opens down, or opens up. Think about that. I think you can see when we FOIL this out, we get x squared out in front, which is positive. So I think this thing is going to be opening up. Also, parabolas have an axis of symmetry, right? So halfway between here, which is right here, this is going to be our axis of symmetry. So we know that on that line somewhere will be our vertex of our parabola. All right. Let's look for like f of 0. So f of 0 will give us our y-intercept that we're talking about in B. And so if I put a 0 in, we get a 0, we get -2, we get times 1, so that ends up being -2. So I know this point is also 0 comma -2 is also in there. Is also a point. And then I know because of symmetry, I know this is a point. All right, now if we wanted to find the exact location of the vertex, we could plug in, we could do f of 1/2, right? We could get that. But, for now, let's just kind of sketch this in. Something like this. Now, don't go way beyond here, right? I mean, this probably is a little steeper here, but don't go beyond this point, right? If you start going up here, then you better put in, like, let's say, f of 3. So if you put a 3 in here, what do you get? You get 3 minus 2, which is 1, and then 3 plus 1 is 4, so you end up with 4. So what I'm saying is don't draw your curve any further than the points you have, but now that we know f of 3 is 4, then I can plot that. So f of 3, 4. 1, 2, 3, 4. Okay, so now if you wanted, you could take it up that far. But don't take it up past where your points are. We had this point, we had this point, and this point, and this point. Now we have this point. We also know that that point is one of ours as well because of the axis of symmetry. So if you want it to do more, you can do a couple more, but that's generally what our parabola would look like. You'd be okay. All right, so let's go on to example B. So on B, we have a degree 2 and a degree 1. So a multiplicity of 2, multiplicity of 1 for our two solutions. So we have another solution at 2 and another solution at -1. So similar to what we had before, but this is not a quadratic. This is going to be a cubic. So we know our end behavior. We know on this side it's going to be going up, and on this side it's going to be going down because it's an odd degree, and the leading coefficient, if I FOILed all this out, the leading coefficient would be positive. So if it was negative, it would get flipped the other way. It would start up here and end down here. Okay. Now, we should probably go ahead and put in our x value of 0 again. So find f of 0. In this case, I think you'll see that f of 0 is 4. And so we have 0, 4. We have this as a point as well. Let me make these points a little bigger. And then let's go ahead and put in f of 1. So if we put f of 1 in, what do we get? So f of 1, that's negative 1 squared is 1, and then that looks like 2. Right? So f of 1 is 2, so we're here. Okay, and then we might plug in f of 3 just to kind of get a sense of what this is, f of 3. And I think if you look at that one, f of 3 is going to be 4. If you plug a 3 in, that gives us 1, and 1 squared is 1, and then you get 4. So 1, 2, 3, 4. Okay. So now I think that's probably enough to kind of get a good sketch in. So it's going to come down again. It's not going to be way out here, but it's in this side. It's going down, right? So you got something down here. Again, don't go very much past this point because we don't know. Like unless you put negative 2 in, maybe that point's here. Maybe it's not. It might be very steep. It might not cross this line in the graph that we have. All right. So it goes up, hits this one, comes back down, hits that one, and goes up. Now notice this 0 that we had, x equals 2, right? X equals 2 is the solution from this binomial. It has a multiplicity of 2. That means when it comes down to this one, it's not crossing through, but it's an even multiplicity. It bounces off and goes back up, okay? And so we have our arrow going up here, our arrow going down here. That makes sense? So this one has a multiplicity of 1. It goes right through it. But this one has a multiplicity of 2. So we know it's going to come down, touch it tangentially, and bounce off and go right back. All right, let's look at a similar zeros, but we have different multiplicities on this one. So let's start with our 0. So we know x equals 2 is going to be a 0. X equals negative 1. Again, same zeros, same real zeros. So negative 1 and 2. All right, and then let's put in f of 0 to find our y-intercept. That ends up being negative 2. So we're down here. All right, and think about what the degree is. The degree here is going to be degree 4, right? The degree is 4. That means the end behavior is either both going up or both going down. All right, so we can see that the degree is 4, so we have to think about like how is this opening up, right? We need, and then also think about the degrees, right? So degree 1 here, multiplicity of 1 for this 0. So it's going to cross right through this thing. And then this one is going to have a multiplicity of 3. So that means at some point it's going to come down, go tangential, and go through. Or if it's coming up this way, it's going to go hit tangentially and go through this way. So we have to kind of figure out, like, well, which way is it going? Like, how is it going to pass through that thing? So we know that if we FOILed all this out, we're going to have a degree 4, which means they're both going to go up. The leading coefficient's positive, so that means it's going to be up on this side and up on this side, right, ultimately. So that means we should look at this coming down, right through, hitting this, and then like we might want to just put in like, f of 1 maybe. So f of 1, if we put that in, we should get something like negative 8. And so we're down here. So that kind of changes dramatically. What instead of bouncing back up towards this thing, it's going to come down. Oh, wait a minute. So wait a minute. I'm switching these two. Sorry, I realized that negative 1 is the one that has the multiplicity. of 3 on it. Sorry, I was reversing those. Negative 2 has a multiplicity of 1. It's just going to go straight through that one. So this one's going to come down, and maybe let's go one more, and let's do f of negative 2. So f of negative 2, calculate that. That looks like it's 4. And so here, over here at negative 2, we're up here at 4. All right, so it's coming down from there. It's going to go through this one, but it's going to go through tangentially. It's going to flatten out at the bottom. It's kind of small, so it's hard to really get that exactly in there. But it's going to come down, touch it tangentially, go through, and then go down and hit 8, and then back up again. All right? That one's kind of hard to do. There's a lot going on in that one. All right, but the whole point is you have to understand how this interacts because of that degree 3. Probably better if I had zoomed in on this a little bit and gave you a little bit more space. But it's going to cross through here, come down, touch that point, come back up. And this one crosses straight through. It has a multiplicity of 1. This one has a multiplicity of 3. We know it's going to go through it. It's not going to touch it tangentially and bounce off. It's going to go through it tangentially, going to touch it tangentially, and then actually pass through it and not bounce off because of that odd degree. All right, let's look at D. So D, notice we have 3 zeros. All of them are multiplicities of 1. So let's plot those zeros. So first one's going to be 0. Next one's going to be 3. And the next one is negative 2. Now think about this. This is if I FOIL this out, it's going to be a degree 3. It's a negative, so instead of starting down and ending up, it's going to start on the left up and on the right end down. All right. So think about where that's going to go through. Now you might also just plug in a couple more points to help us kind of see like, well, how far down does it go? How far up does it go? So we might try the points in between these to help us kind of get a good picture of what this looks like. So we might try f of negative 1. We might try f of 1. So get negative 1, 1, and 2. All right, f of negative 1. Looks like it is negative 4. And f of 1 looks like it's 6. F of 2 looks like it's 8. All right, so let's plot those. So at negative 1, we're down here at negative 4. At 1, we're up at 6. 4, 5, 6. And then at 2, we're up here at 8. Okay, so kind of sketch through again. Don't go way up here. Just kind of start here. We're going to go straight through each one of these zeros. Something like that. Again, don't go much past the points unless you're checking the next data values, right? So you could put in a negative 3 if you wanted to figure out like how steep this thing should go. But we knew it starts left going up and ends right going down because of the negative coefficient. All right, let's try the next one. Here we have 4 different real zeros. So we have one at 1. We have one at negative 1. We have one at 2. And we have one at negative 2. All right, so think about what the graph of this thing will look like. It's a degree 4. They're both going in the same direction in the end behaviors. And what would is the leading coefficient going to be positive or negative? And I see if you FOIL all this out, you'll just get x to the positive x to the 4th. So the end behavior is going to be going up. Probably good to do f of 0 here. And if you get that, if you plug 0 in, you will get a positive 4. All right, so at 0, we're up here at 4. And so, you know, again, I'm not going to go much past these. We're going through it, going up to this one, coming back down. Oh, sorry, missed that one. Coming back down, crossing through this one, and again. And again, we're not expecting that, you know, how far down does this thing go? Well, if you wanted to put in, a value between -1 and -2, but this is all we're sort of expecting you to do. And again, don't go, unless you put in a -3 into your function, a -3 or a 3, don't go past those. So just stop where the points are so that you're not going to get yourself into trouble. Okay, next one. We have a multiplicity of 2 here. Ooh, we have a multiplicity of 3 as well, and a multiplicity of 1. So we have -2. That's a multiplicity of 1. That means it's going to go straight through. We have a 0 at -1, so that's going to be a bounce off. It's going to hit it tangentially and go right off. And then we have another 0 at 1, and that's going to be a multiplicity of 3, so that means we're going to go tangential, but also pass through it on the other side. Okay, let's think about how many degrees we have, right? So we're going to have degree 6, so that means they're either going to both go up, or they're both going to go down at the end. I think you can see if we FOIL all this out, we're going to have a negative leading coefficient, so that means this one should be going down on this side and down on this side. All right, so, and again, if you're going to plug in other points, I guess we should probably do f of 0 at least so we can see like where this one's going to be. And if you put in f of 0, I believe you get 2. All right, so now we're going to go straight through this one, right? So we're going to start down here and go straight through it. Then we're going to, at some point, turn around. And again, where this goes up, if you wanted to put in -1.5, but we're not really so concerned about that. So it's going to go up some, it's going to come down. This one has a multiplicity of 2. So it's going to come down, touch it tangentially, and bounce back up. Let me see. Let me do this a little better. It's going to bounce off, come back up, go through this point, and then what happens here? It's a multiplicity of 3. So it's going to come down, go through it tangentially, and then go down. Okay? So we have 3 zeros here. We have 2 zeros here, multiplicity of 3. So we have a triple root. We have a double root. And then we have a single root, right? So it goes straight. This one goes straight through. This one's tangential. It's degree 2. So it's tangential, bounces off. This one's degree 3. So it's tangential and goes through. Okay. And again, these aren't going to be perfect graphs. We didn't take care as to how high this one goes. We're not going to have you be putting in negative values and everything. I mean, half values, decimal values. We're going to have you put in, integers and kind of get a rough feel for what it looks like. All right. These 4 graphs are specifically asking you to look at the end behaviors. So, for example, this one. As x goes to -infinity, so as we go out this way in the negative direction, what happens to the y, or f of x? It's going to positive infinity. Remember, too, that if the graph goes off the edge, if the curve goes off the edge, assume it keeps going. If we stop it sort of in the middle, then assume that that's the end point. But these are all going to the edge of our graph, so we're going to assume that all of these keep going. So there's really arrows here. It just doesn't do a good job. The software I use doesn't do a good job of putting those arrows in. So assume those arrows go on forever. So as x goes to positive infinity now, what happens to f of x or y? It goes down to negative infinity. So that's kind of how we demonstrate the end behaviors by doing that. So x goes to negative infinity. So again, as we go in this direction, more and more, this thing is exploding in the positive direction. So y, or f of x, is going into positive infinity. As x goes to positive infinity, what happens to the y? Y also goes up to positive infinity. So do the same thing for these. So as x goes to negative infinity, goes in that direction, x direction, what's happening to the y, or f of x? F of x is going also in the negative direction. It's going down. As x goes to positive infinity, what's happening to f of x? It's going to negative infinity. Okay, it's the end behaviors. That's how we will sort of describe the end behaviors. For this one, what's happening as x goes to negative infinity, to the, not negative 8, negative infinity, what's happening to y, or the f of x, it is going to negative infinity. And this one, as x goes to positive infinity, what's happening to the f of x, it's going to the positive infinity. Oops, keep making 8s. And positive infinity. Okay. All right, next one. We're just simply asking you to match these. So pause this video and try to match each of the 4 functions. Put an A, B, C, or D next to each one of those. All right, so we'll use the degree. So this one looks like maybe a degree 3, but at the very least, it's going to be an odd degree, right? And we saw in that video, sometimes we see things that look like degree 3, but maybe they're really a degree 5. So this could be degree 3, it might be a degree 5, but we know the leading coefficient has got to be positive because it starts negative on the left, ends positive on the right, so our leading coefficient's got to be positive. So here's an odd degree, here's an odd degree, the other 2 are even, so this one would have to be a leading coefficient that's positive. So this has to be A up here. Okay, g of x has got to be A. Or if you want to just do this one down here, g of x, maybe that's better. Okay. And so let's look at the other one then. So this one, opposite direction, so it's got to be an odd degree. So that has to be h of x. H of x. Okay? H of x, or we could call this one d, however you want to do it. Okay. Now the next 2. They're going to be even degrees, right? Like maybe they're degree 4, but maybe they are degree 6. Can't really tell. But in this case, this has a negative leading coefficient. That means they both got to go down, so that's got to be this one, right? So this has got to be f of x. And this one is a positive leading coefficient, right? So that means they both got to end up, and so that's got to be this one. This has got to be k of x. Okay? All right, so that's page 1. What we're going to look at next is sort of graphing them a little bit with a little bit more detail maybe. Let's look at example 4. Graph this function. All right, find and plot the zeros, and then find and plot 0 f of 0, or the y-intercept. And then we'll think about considering the end behaviors, and then plot extra points as needed to figure out which, what it's going to look like. All right, so let's see. Find and plot the zeros. Okay, so let's just try finding some zeros, right? So this one's not in factored form. It's a degree 3. So to find the zeros, unless we're going to just start plotting points and hope to hit a 0, let's use some synthetic division. All right, so our x, and let's see, it's a degree 3, so 4 terms, so 2, 5, -1, and -6 with our remainder line here. So let's just try 1 to start with. And so we bring down the 2, we multiply, that's 2, add it to the 5, that's 7, multiply that 7, subtract 1, that's 6, multiply that 6. Okay, so we got lucky. Our depressed polynomial, so essentially we've taken this thing and we factored it into x minus 1 times 2x squared plus 7x plus 6. All right, so we've taken this polynomial function and we factored it. So that gives us our 1, 0, x equals 1 is one of our zeros. That's what this tells us here, right? And then we could try factoring the rest of that. That's the depressed polynomial, and see if that factors. If not, we would have to use quadratic formula. You could probably assume for these types of problems, we're going to give you zeros that are integers, or worse, like a half or maybe a third or something like that. They're not going to be too bad. Okay, so then certainly rational. we wouldn't ask you to graph things that were required with the quadratic formula, at least not at this stage. All right, so 6, probably 3 and 2, so let's try 3 and 2. That's going to be 4 plus 3, that's 7, so it looks like our two solutions, or our two factors should be this. All right, and so that gives us an x value of -3/2 and an x value of -2. All right, so let's see. Let's plot our points. So we have, you know what? I'm going to change the scale just so that they're spread out a little bit. That's 1, that's 2, and that's 3 in the x. That's -1 and -2 and -3 in the negative x. So let's see. Let's put our point here. I'm going to put like a 1 above that so we can know that that's a 1. I won't change the scale on the y. I'm just changing it on the x. Okay, we have -2, so that's here. And then we have -3/2, so that is here. All right, so they're all multiplicities of 1. Think about the leading coefficient is positive. So I know it's degree 3. It should end down, start down to the left and end up on the right. So we're going to go through these. Let's find maybe some more points. So let's find f of 0. So we'll do f of 0. Let's also do f of -1. F of -1. We can either put it in like these factored ones or plug it into the original one, up to you. In this case, f of 0 is -6. That's just our constant. -1, when you plug that in, you get -2. So let's add those to it. 1, 2, 3, 1, 2, 3, 4, 5, 6. I didn't change the scale on the y-axis. I just did it on the x-axis. The y I left alone. All right, so that's 1 point, and then we have -1, comma, -2. So we're here. All right, and so we're going to do something like up here, then down here, then it's going to cross here and go back up. Now, maybe not the smoothest of graphs that I've made. Keep looking at the camera instead of looking at my paper. So something like that, okay? Now, we don't know if this is the minimum value. It might cross over here and go down further up without putting in more, decimal values. But again, this is as good as we're going to expect you to do. All right, now we're going to work backwards. We want you to, we have the function, we have the graph of the function. I want you to write the polynomial function. So f of x equals, and then let's maybe expand it out too, maybe. But at the very least, we have to think about what the coefficient might be in front. So anyway, so let's think about our zeros. And so we know we're going to have, okay, it crosses at -2, so that's, it touches at -2, so that's going to be x plus 2 is going to be the resulting binomial for that one. We're going to have x minus 1 because it crosses at 1, and then also at +3, so x minus 3. Now, think about what multiplicities we might need there. Also, notice I left a little space here because I'm going to write something in there in a second. So what multiplicities would we have? Any of them degree 2 or degree 3, and you can see here at -2, we definitely have a multiplicity. Let's assume it's 2. I guess in theory it could be degree 4, but we're going to keep it simple and just assume that it's 2. Okay, and then you can see here that we're going to have degree 4, which makes sense. They're going in the going in the same direction, so degree 4 makes sense. That's even. But notice that it crosses the y-axis at -12. So that means f of 0 equals -12. So we're going to have to think about some a in front here, right? Because if I just multiply all this together, I would end up with a coefficient, a constant at the end looks like positive 6. So without doing any kind of switching around, I would be crossing up here at 6, and clearly mine doesn't do that. So we need this A. This A we know is going to be negative, but it's also going to have to stretch this thing in the y direction some. So if we were to FOIL all this out, we know we would have x to the 4th, and then we'd have stuff in between, and then we'd end up with a 12 at the bottom, at the end, right? If we multiplied, we needed this to be the case. So with the A out in front, right? We know that this would be if we put a 0 in, if we put a 0 in for the x, then we would end up with A times the 12, and that's equal to negative 12, right? I mean, we're looking at the function. So if we do like f of 0 in, I'm expanding all this out, but all these are going to go to 0 anyway. So I'm just going to get A times 12. Then A times 12 is equal to negative 12. And so I think you can see that A would be equal to negative 1. Does that make sense? Yeah, because I'm thinking this I was thinking before I was saying how 2 times 3 is going to give me 6, but it's actually 2 times 2, which is 4, and because it's to a multiplicity of 2, so we would definitely get a 12 if we expanded all this out. So without a negative 1, the graph would actually be flipped. Then we wouldn't have to worry about the leading coefficients. So in this case, if we just went back up here and put in a negative 1, then this is essentially the answer, right? But you have to take into consideration this 0, the y-intercept, to be able to figure out what would the leading coefficient be. We knew it had to be negative because these things go down instead of going up, so we knew that was the case. Okay, the last thing. Now, this one is we're going to actually use our calculator to do some calculations and do some approximations. So we're going to actually graph. And so we have something called the intermediate value theorem. And then if this means that if the sign changes, I put an f of a in, so some value a. I find what the function's value is at a, and I find what the function's value is at some other value, let's call it b. And if the sign changes between these, then whatever the a and the b are, I know that between those 2 points, there has to be a 0. All right, so if we put this to work for this problem, I think this will make more sense. All right, so we're going to approximate the zeros to the nearest tenth. So up to this point, all of the zeros have been nice, nice rational values. They're not going to be here. All right, we're going to ask, sometimes they might be, but some of them are going to be maybe even irrational. So we're not going to use synthetic division this time. What we're going to do is we're going to find these by graphing. And we're not going to find the actual 0. We're going to just get to the nearest tenth. All right, so I sort of set this up. It'll make some more sense for why we set it up this way in a minute. But you can see I started with -3, -2, -1, 0, 1. So not bad values to just start with, and then maybe a 2, or we'll see what's going on with these values. So if we plug a -3 in, now you're going to use your calculator for this. All right, you're going to take, you're going to do the negative of -3 cubed. So you're going to type that into your calculator. Minus 5, and then wherever there's a substitution, I'm going to put in parentheses so that I make sure that I'm raising the negative to that power. So we're going to raise that to the second power. Minus 3 times -3. I'm running out of room. I should have written a little bit smaller here. Plus 5. Okay. Actually, let me rewrite that so it's smaller, because otherwise it's going to be confusing. All right. So we have negative of a -3 cubed, and then minus 5 times -3 squared, minus 3 times -3 plus 5. So you're going to type that into your calculator. Let me type it in and show you what I mean. So if you have a decent calculator, you should be able to type all of this in and sort of see it, but mostly. Hang on, let's see. Still typing mine. So type yours in at the same time. So we have 3, the exponent, and then subtract 5 times negative 3. And then we want that squared minus 3 times negative 3. I will show you mine. Look, I'll show you kind of how I'm typing mine. There's a little bit of a glare on mine, but so I'm typing it in times 3. Be careful of your subtraction of 3 and your minus 3. The calculator works with those differently depending on your calculator, and it will give you an error if you don't type it in properly. And then finally plus 5 at the end. And when I hit return, I get a negative 4. All right, so I get a negative 4. Now, what's great is you can recall the previous thing in your calculator. So if you hit different calculators do it different ways, but if I with my calculator I can just go back up. No, let's see, that's not it. Let's see, I can do second enter, I think, and it recalls the previous thing. And I can go up and change it. So that's what you really want to do, is you really want to just go and change these negative 3's, because how we typed them out, they're nice, they stand out, they're in parentheses. Go and type those, retype those as 2's. So a negative 2, scroll back through and do negative 2. And this will save you a lot of time and not have to retype the whole thing every time, because otherwise this can be kind of tedious. All right, so I'm going to hit that one. That gives me negative 1. So negative 1, I'm not going to bother writing all that. And then do the same thing. Recall your calculator. You just got to figure out how on your calculator you do that. And I'm going to go back and change my 2's to negative 1's now. Negative 1, and then one more up here, negative 1, hit enter, and then it'll calculate it for me. So that's a 4. The 0 is easy, right? That's just going to be 5. Okay, and now the 1, that's a little bit trickier. What I would say is recall the previous thing again, and then what I would say is we want to type in a positive 1. I would say just type 0, 1. That way you don't lose the 2 spaces in case you want to put a negative back in there in a second. All right, so go and just type, instead of negative 1, type 0, 1. And so go back and change all of those. And again, it's just quicker and not have to type the whole thing again. So the whole point is you got to type it in the first time pretty nicely and make sure that you get it right. All right, and that one is negative 4 as well for 1. All right, so let's plot those points, those 5 points, and let's see. We know kind of what the shape should be because of the degree and the leading coefficient being negative, and we'll use that to sort of help us decide what other points we should look at. All right, so let's start. At negative 3, we're at negative 4, so we're somewhere around here. Okay, and then at negative 2, I'm at negative 1, so I've gone up to negative 1. And then at negative 1, I'm up at 4. Okay, so that means somewhere between negative 2 and negative 1 x value, I have a 0. I'm crossing there somewhere because here it was negative, and here the y value is positive. That means, and that's what the intermediate zero theorem says. If f of a is negative, so f of negative 2 is negative, f of b, or f of negative 1, is positive. That means between negative 1 and negative 2 and negative 1, there has to be a 0. The graph has to cross the x-axis somewhere. It's negative here, over here, it's positive, it's got to cross. And in theory, I suppose it could cross a couple times, but we're not going to give you any that kind of have a bizarre reaction like that. So it's just going to cross once through there is what you should assume. All right, and so then, let's see, at 0, we're up at 5. And then at -1, we're back down at -4. All right, so I know there's also a 0 between these two. Okay? Now, let's kind of sketch in what we have so far. We know it's something kind of like this. This one's pretty steep and it comes down. All right. So now where should we look for more zeros? Will this thing come around and go back up this way? Or will this thing come around and go back up this way? And we know which one is going to happen because that this is a degree 3, right? We know it's going to turn around and come back up. Without that, it would be more like a parabola, and we'd have 2 solutions. So we need another one, and this is negative. So I know it's not doing this. This is going to go continue in that direction. This one's got to turn around and bounce back up. Now, that tells me that I need to go back and look at -4. So it's why we left some spaces here, right? I don't want to go and put -4 here. I want them in sort of numerical order, because then this number I'm going to have to compare to that number, not the one next to it. So don't put -4 here, put -4 up here. Okay. And that's why I left a space, because you don't really know when you start which direction you're going to be going. So -4. So good thing we didn't get rid of the 2 digits, because I want to go back in now and put a -4 in here. So recall the previous calculation and then go and change your 0, 1, which is the last thing we put in, right? We put in this 1 here. We want to put in -4 now. So change all your 0, 1s to -4, and make sure you're using the negative sign and not the subtraction sign. Okay, because that'll give you an error. Subtract, that I mean -4. Okay. All right, and then hit enter, and that is 1. Okay, so that means at 4, we're at 1. That means, oh, we've crossed it again. All right, so now our goal is to figure out, to estimate that 0, and that 0. So this is a more tedious process. So now we're going to create a couple more graphs, a couple more sort of tables almost. All right, and again, leave some space on either side because you don't know what direction you're going in, right? So we start with -4.0. We did that one, and that is 1. Okay, so we start here. Now, I want to go in that direction, don't I? So I'm going to go by tenths because we need it to the nearest tenth. So I'm going to go negative, going in that direction, -3.9. Okay, and now at this point, I think it's probably best if we type it all again. So we have negative, let's see, we have -3.9, with a negative out in front of that, cubed minus 5 times -3.9 squared minus 3 times -3.9 plus 5. So type all of that into your calculator kind of fresh this time, because we don't have, we only have space for 2 things, 2 digits, a negative and a 4. We need a negative, a 3, a decimal point, and a 9. So we need space in our numbers for 4 things. So I think it's best if we just start over typing this. So we get, let me just clear my screen, and we do negative parentheses, -3.9. Close the parentheses. I'm going to raise that to the 3rd power. Okay. And then I'm going to subtract 5, parentheses, -3.9. Close that parentheses. We're going to square that. Then we're going to subtract 3, parentheses, -3.9. Close that parentheses. And then we'll do plus 5. All right. Let's see. I typed this wrong. Hang on. We did -3.9. I did my negative and my 3 backwards. Okay. So I think that should work. Let me hit enter, and I get -0.031. So I get negative 0.031. Now notice, going over just a tenth took me down, and now I'm negative. Okay, so that means there's a 0 between these two. Between these two x values, we crossed over from positive 1 to negative 0.031. Now, we'll pick whichever one of these is closest, has a y value closest to 0. Clearly, this one is closer to 0 than positive 1. And so we'll say x is approximately equal to negative 3.9. We found approximated our first real 0. Okay, now we're going to try the same thing for this one. So let's see. Let's start this one. Let's just start at negative 2. All right, so let's start at negative 2. I'm going to say negative 2.0. We know what that value is from up above. That gives us a value of negative 1. Okay, so now, which direction do I want to go? Well, we're below. Over here, we're above. We want to go in that direction this time. Okay, so we want to go, more positive. So we want to try maybe negative 1.9. All right, and so we do that in our calculator. So we can recall that previous answer, and we just want to go back in and change negative 3.9 to negative 1.9. So we just change the 3 to a 1, so you can see how quick this is. We want to change this 3 to a 1 as well. And finally, this 3 to a 1. All right, and hit enter. And we get, let's see, sorry, I cleared that somehow. I somehow got back to my 3.9s. All right, let me try that again. All right, so when I do that, negative 1.9, somehow I deleted that. I got negative 0.491. Okay, so I'm still negative. So I went over a tenth, and I'm still negative. I have to keep going till I see a sign change. So I'm going to keep going in the same direction. I want negative 1.8. I typically go by tenths. Because if I say like, oh, that's too low, let's jump up to negative 1.6. All right, so that sign changed. Now what? Now I got to go back and I got to bounce back and forth, and it gets really complicated. So you really want to go by tenths. So that way when you do see your sign change, it's not a horrible issue. Now hang on, let me see if I can get back to... I don't know. I'm going to have to retype mine. Something I cleared something in my calculator or something. Yeah, I don't know. Not sure what I did. So let me just retype it again. Okay, so this time it's negative 1.8. So I have the negative of parentheses, negative 1.8. I'm going to close that parentheses. We're going to raise that to the third power. Then I'm going to say minus 5, and then negative 1.8. That's going to be raised to the second power. Then I'm going to do minus 3, 3 times parentheses, negative 1.8. And then we want to add 5. Okay, so I do that one, and I do get a positive this time. I get positive 0.032. So I know that I switched signs here, so my 0 is going to be one of these two, or at least closest to the nearest tenth, one of those two. Which one of these y values is closest to 0? Clearly this one. So my x is going to be approximately to the nearest tenth, negative 1.8. Okay, so that's how we found this one, and now we have one more to do. And this one, I don't know, it's kind of, you can look at the graph to kind of help you, but, we didn't know if we really graphed this perfectly. So we could start kind of in the middle there. Let's start with 0.6, 0.6. It's between 0 and 1. I'm going to try 0.6. Actually, I don't have much room on the bottom here. Let me do it up here. So I'm going to do a new table sort of over here. I'm going to do 0.6, 0.6 for this value here. Okay, and then if it is positive, then I know I got to go further to the right. If it's negative, then I have to go back and to the left, right? So it depends on what my value gets here, which way I'm going to go. All right, does that make sense? Because you could start at negative, you could start at 1 and work backwards if you wanted, but I'm just thinking let's start a little bit more in the middle. It looks like this might cross a little bit more in the middle, so I'm going to start with 0.6. So again, what you could do is just go and change this last thing, this negative 1.8. You want to change that to just put in zeros. Let's recall it. And so then I'm just going to, so I don't have to retype it all, just type in 0, 0.6. Does that make sense? Because you needed 4 digits before, 4 spaces. You needed the negative, you needed the 1, you needed the decimal point, you needed the 8 for the last one. So now you could just type 0, 0.6, and that way you don't have to worry about deleting things or anything. Just use the exact same spaces that you have. So 0, 0.6 looks weird, but the calculator is happy with the zeros. It doesn't mind. And then lastly 0, 0.6, and enter that one, and we get a positive 1.184. All right, so I'm positive. I'm up here. So at positive 0.6, I'm positive. So that means I've got to go further to the right because this one's going down in this direction. It's sloped like this. So in order to go down towards the negative, I got to go further to the right. So that means I'm not going to do 0.5. Instead, I'm going to do 0.7. All right. And so again, we can do that pretty quickly. Pull up the previous thing. Just change our 6s to 7s. 7. 7. And the last one, 7. All right, and so that is still positive, so that gives me 0.107. So we're getting close, and so we need to do one more, 0.8, 0.8. So we started at 0.6, we were up here at 1.1. I went over a tenth. I'm down here at about a tenth or so, and now I want to go one more 0.8. So again, recall and change your 7s to 8s this time. 8, and last one. I suspect this will give us a negative value, and it does. So it's negative 1.1, so negative 1.112, and so sign change happened between these two, so that means one of these two is going to be, the 0 is really between these two, but we're just getting it to the nearest tenth, so we pick whichever one of these is the closest. Whichever one of these has a y value closer to 0, clearly this one is, so we're going to say that x is approximately equal to 0.07. All right, so those are our 3 solutions. A little tedious, but if you take a second to set the equation up in your calculator, thinking ahead, then you'll be able to plug these in pretty quickly. Other than that, it just takes forever to type all this in, and it's very accident prone. Okay, so here are the problems for homework tonight. Due next class, and remember these are multiples of 4.